Hi, hope you're all very well. I hope you had a lovely holiday. Now obviously I can't actually see you because I haven't got my glasses on, but they get a bit shiny, so I just thought, there we go. The weather's been fabulous, so I hope you've been outside and enjoying that. And I'm sorry we're not back at school today. I really wish we were. Anyhow, we're going to do, there's a couple of things that we just need to teach you, which we were hoping to do in school, but given that we're going back quite late, we probably won't now. So the first of these is parts of a circle. This is a nice, easy thing to get to grips with, because in year 6, you don't need to know all of the parts of a circle, you just need to know a few of them. And some of you probably know these already, so let's go. Or not, why isn't it moving on? Move on. Okay, so there's a circle. Hopefully you know what a circle looks like. And then that bit in the middle there is the center of the circle. It doesn't quite look like the center, but I'm sure it is. And the center of a circle, we call it the fixed point. It's a fixed point. If you were drawing this circle using the pair of compasses with the point and the pencil, you put the point in the center of the circle, and then you would move out your pair of compasses with the pencil on one end and draw around it. So the center of the circle is called the fixed point. Okay. And that line there is half of the width, half of the length from the fixed point in the middle to the outside of the circle. And that is called the radius. Okay, so that's the radius of the circle. And the radius just goes halfway from the fixed point in the center of the circle to the outer edge of the circle. That's the radius. Okay. Oh. And the radius could be anywhere, of course. All of the radius around, every line there is a radius, is what I meant to say, sorry. So every line that goes from the fixed point in the middle to the outer edge is a radius, and each of the radius is the same size. Okay, so if you think about it, that's how a circle is formed. If you had a radius that was longer than another radius, then the circle wouldn't be smooth, would it? The circle would be jaggedy like that, because all the radius would be the wrong size, the radii. Okay. Oh, here's an example of why. I'll play it. This doesn't look like the right thing. Play. That's because it's an advert. Let's move on. Skip on.
Hey, what you doing? Daydream. What is a Heinemann daydream about?
I'm going to move this on a bit because it's a bit we want. If you want to look it up, you can later. This is what happens if you're if the radius that you draw isn't the same all the way around the circle.
Here we go. Moment of truth. Rear wheels, smooth ride. All 4 wheels flat. And 3, 2, 1, go.
They're off to a bumpy start.
Doesn't look very smooth.
Right out. But as Jamie accelerates, the ride seems to get smoother. At least until it suddenly stops off.
So as you can see, that's not a very helpful. Wheel to have. So, but if your radius was a different size, it would have jaggedy edges on your circle, wouldn't it? All the radius that goes from the center, the radii that go from the center, have to be the same size. So the line that goes straight across the middle, and there's our fixed point again, is called the diameter. Okay, so the diameter goes from one end of the circle through the fixed point to the other edge of the circle. So it goes from one edge of the circle through that fixed point in the middle to the other edge of the circle, and that's called the diameter. So the diameter is twice as long as the radius, because obviously the radius is going halfway and the diameter is going all the way across the circle. So we can say that the diameter is 2 times the radius. And if we're writing that in a more algebraic form, we'd say D is 2r. Diameter is D and r is radius, so D equals 2r. Remember, if we're writing an algebraic expression and we're saying 2 times r, we put them together to say 2r. D equals 2r. So an easy question. If the radius of a circle is 14 centimeters, what is the diameter? Just have a think. I'm sure you know that it's 28 centimeters. Perfect. Okay, so if we look at the edge of the circle now, like that, that's called the circumference. That's the distance. It will be a perimeter in a rectangle or a triangle, but in a circumference, in a circle, it's called the circumference. It goes all the way around the outside. Okay. So those are the only three names that you really need to know in parts of a circle. The radius, halfway across, diameter, all the way across, and the circumference, all the way around the outside. Of course, the radius and diameter relate to the center point, the fixed point in the center. Okay, perfect. So if we look at this, this diagram here, and we can say that the radius of each of these circles is 6 centimeters. What is the width of the rectangle? Okay, so you can see there's 3 circles there, all joined together, all touching. So what is the width of that rectangle? The width is the long, the width is the short one, sorry. The width is the short one at the side here where I've labelled it width. I'm so silly. So what is the width of the rectangle? Have a stop of the video and just see if you can work that out. The radius of each of the circles is 6. What's the width? Okay, so hopefully you noticed that. Let me just see if I can get the pens on here. Okay. I know now that you can't see these pens. When originally I thought you could. So let's see. If that, oh no, that's not right. Let's try that again. Erase. So where's the pen? I don't know. I'm sick of all these different kinds of, right, yeah. So if that's not a very straight line, but imagine that's a straight line. That's one radius, so that's 6 centimeters. That's not coming very well, 6. And then the other radius here goes right the way across, that's another 6 centimeters. So altogether the diameter, oh, make myself bigger. Altogether there, the diameter is 12 centimeters. So the width, because the rectangle is pushing on the side of the circle, so the width there is 12 centimeters. I didn't explain that very well because I was getting confused about the pen, so let's try that again. I'm sure some of you understood that, just being a bit silly. So we've got from here to the center circle is 6 centimeters because we know that the radius of each of the circles is 6. And there are 2 of those, aren't there? Because that's one radius and that's the other radius. 1, 2. Okay, and then so that makes the width altogether 6 centimeters. Okay, lovely. And then we want to know what the length of the rectangle is. Okay, so have a think, stop the video and have a look at what you think the length, the long one is. You know that the radius of each of those circles is 6 centimeters. What do you think the radius, the length of the rectangle is? Okay, so if we know that the radius of each of these centimeters, oops, oh, what would happen? If we know, let me try that again, that the radius of each of these rectangles is 6, we also know that the diameter is 12, don't we? Go all the way across, and that'll be 12 centimeters, just like it was for the width. And then we've got 3 of the circles, so each of those is 12 centimeters. Okay, so the length of the rectangle from here to here is 12 times 3, which is 36 centimetres. Okay, hopefully you understood that. Just to make that clearer, I don't think I made it very clear. Just in case some of you haven't got it. Of course, these should all be matching. It's a very imprecise tool, this one. Okay, perfect. Oh, I can't get this off now. Okay. So, oh, that's interesting. Didn't think it would keep that, but let me get rid of it for you. So if we look at how to use a pair of compasses, and a pair of compasses, obviously you may have some at home, which is great. If you don't, it's not rocket science to try and use one, but let me just show you how to do this. So you take your compasses. Now sometimes they're very slack when you do them, and obviously that means it's going to slip when you try and use it, so that's why they're screwing it together, to make it really, really stiff when you pull them apart. It should be harder to open. Okay. He's very slow. Oh no, maybe no, it's him. And then you put your pencil in. Now you can't have it too short, otherwise you won't be able to see the mark. So the pencil point should be just slightly beyond the point of the compasses. And then you use that wheel there to tighten the pencil so it doesn't fall out. Okay, then you measure whatever your radius you want it to be. So in this case it's going 4. So it's 4 centimetres, this one, and that's the distance halfway across, remember, so the diameter of the circle will be 8, won't it? Then you have to kind of lean the pencil over to make sure it makes the mark and drag. Don't press too hard because the pencil will move. And look at the compass point, okay? That's how you draw a circle. You can obviously just move the paper around as well. Oh, cancel him. You don't want him. Oh, shut up. I can't get rid of him. Please stop talking. Thank you. Okay, so if we go back to our PowerPoints, that's how to use a pair of compasses. And then there are some ways that you can draw a circle without a pair of compasses, and I've put those videos on there. I am going to put this amazing presentation onto Google Classroom separately so that you can look at those 2 videos in particular, and you will have some My Maths tasks to do just to check your understanding, and I'll be able to check in and have a look at how you've got on with those. So good luck, hope it goes well, have a great week. Oh, I'm still here, hang on.